On this Indiana expedition, we'll learn that all matter has mass and takes up space. We'll investigate magnetism at an Indiana steel recycling plant. And can physical science keep me afloat?
Try it yourself. Let's go check it out. Come on.
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas, and promoting environmental education, stewardship, and awareness. CEFI, the Science Education Foundation of Indiana, investing in Indiana's youth by encouraging them to become scientists and engineers and to practice their careers in Indiana. Details at sefi.org. And the Center for School Improvement and Performance, Indiana Department of Education.
Every physical object we know of is composed of something called matter. The difference is different objects have different properties of matter. For example, two bowling balls, same color, same size, but are they made of the same stuff? There's only one way to find out. Investigate their properties of matter.
As you can see, these bowling balls aren't the same after all. One sinks and one floats. This is because they have different properties of matter.
Today, we're going to see how matter and properties of matter are beneficial to mankind, or at least entertaining to mankind. This is science. Try it yourself.
Matter is the stuff that things are made out of. All matter does two things. It takes up space and it has mass.
As a teacher, understanding science and physical properties of matter is a fun way to get kids excited. For example, here we have two boxes, same size, same shape, they're congruent, but do they have the same stuff inside of them?
We look at the physical properties of matter to help identify what type of matter it is. For example, if something is magnetic, that is a physical property of matter. Or maybe it has a certain shape, or a certain density, or color. All of these things are physical properties of matter that we can measure, see, or observe.
Which one's heavier? That one's heavier, and so it must have more stuff in it. So, which one would be more dense? Box A or box B?
Box B!
Let's find out why. If we open up this box, empty. We open up this box, more stuff. And so this kind of shows you why there's more stuff or more matter than in here. So with this one, more mass, more dense, less dense.
The basics of understanding matter are easy to grasp. What we understand about matter comes from studying the physical properties of that object.
Did you know density is mass divided by volume?
We like to measure density as a comparison to something we all know about, and that is water.
Something that sinks has a density of greater than 1. Something that floats has a density less than 1. Let's investigate the physical properties of butter. The question is, will this butter sink or float? Let's test our prediction. It floats. What does that tell us? It tells us that butter is less dense than water because it floats. But here's the real question. That's just one small pat. What happens if I take the entire stick of butter? This one has more mass. It's still butter. What's your prediction? Does it float? Does it sink? Or does it stay the same? It floats. The reason it floats is because it's still butter. We didn't change its physical property. We just add more butter. Of course, we had to have enough water for it to float. Anybody want to change your prediction? Hey, this is science. Try it yourself.
One observation I've made involves two objects that look alike, but they have two different physical properties. When placed in a small container of water, a Diet Coke will float, while a regular Coke sinks to the bottom. Interesting. What if we tried a bigger container of water? In the aquarium, we get the same data. Diet Coke floats, Coke sinks.
That is pretty cool.
Maybe it's the extra calories. Or maybe we need to try an even bigger container.
1, 2, 3. And they sunk? Ah, but they came back up. Very good, very good. 1, 2, 3.
Same results. I guess we can say that Diet Coke floats. In science, one of the best things to do is to apply what you've learned.
We're putting the Diet Coke suit to the ultimate test.
I'm hoping Diet Coke can keep me floating.
Ah, very nice.
Success. We've learned that objects that are less dense than water will float, and objects that are more dense than water will sink. We could state that Diet Coke is less dense than regular Coke. Now, there are some properties of matter that only show up in certain materials, and at times it can seem like magic, but it's called magnetism.
Did you know the first magnets were called lodestone? Ancient travelers used them to find their way.
Let's investigate magnetism. If something has the property of magnetism, that means that it can attract or repel certain things. But almost all magnets, whether they're big, small, strong, or weak, have one thing in common. They all attract iron. Now, magnets are definitely good to have around the house for displaying artwork on the family refrigerator. They're fun, but believe it or not, magnets are used for so much more.
They say one man's garbage is another man's treasure, and that is really true right here where I'm standing, because I'm in the middle of the huge pile of what some people may say is garbage, but I say natural treasures, iron, the ingredient for steel. So all these things you see behind me are used to recycle to make steel that we use in our roads, our buildings, our schools, and our highways. And it's some things that you probably are familiar with. Tractor seats, bumper, even a basketball goal. All this stuff has one thing in common, one property of matter. It's iron, which means it's magnetic. And it also can be recycled into something we'll use over and over again.
We use our magnets to take the scrap steel that's on the ground into the rail cars. Then the rail cars are taken into the scrap bay to be melted. In this case, a magnet is far more effective because it grabs onto the steel through magnetism, and then when we take the magnet over the rail car, we can de-energize the magnet and it'll release the load.
Okay, so I got a magnet here, so we should be able to do a spot test here, Sean?
That's correct.
Okay, so let me just try a piece right here. This looks like a pretty interesting piece. And if you notice, the magnet sticks right to it. Pretty cool. Here's a piece, let's see. We can come down here and... So basically, this is a different version of what the big machine's doing behind us over here.
Right.
Picking this up and doing it. Pretty neat.
In the production of steel, magnets play a critical role, from the scrapyard to the loading on trucks.
The outside scrap is kind of our inventory buffer, so we receive scrap from all kinds of scrap yards, predominantly within a truck ride of our steel plant. And as they arrive, we stockpile them outside based on economic conditions, and then we deliver them here to the scrap bay based on how we're going to consume them.
Okay, so one of the interesting things about this is a huge recycling plant.
Yearly, we produce about 550,000 tons of cast product steel. Out of that 550,000 tons, we'll actually consume about 600,000 tons of scrap material. We're recycling predominantly 95% of what comes out the other end. What was once a refrigerator, a car, or a washer, dryer, or swing set, we process it into something that can be reused into all kinds of applications, from the aerospace industry to tractors and trailers, to farm equipment, automobiles.
This is just like you try in your classroom. Here's a magnet picking up a piece of iron. As simple as flipping a switch in this case, and having the skills to be able to run this electromagnetic crane.
From there, the scraps are loaded into a large bucket that's moved into the melting area. Steel is an alloy of different metals mixed together. It's almost like a recipe. How you want your steel depends on what you put inside the steel. Steel makers must be very precise because what they put in changes the physical properties of what comes out.
They can control the carbon system as they introduce carbon to the melt.
Too much or too little of any ingredient could change or ruin the entire batch.
This is where you'll add the nickel, the molybdenum, the manganese, silicon. We can add titanium, boron, carbon. In some cases we add sulfur. All those elements are added to the steel to produce the final effect that the customers ask for.
It takes a tremendous amount of energy to melt this steel.
The best thing to equate that electrode to is the graphite in the center of a number 2 pencil. We want to deliver the electricity to the furnace to use it to melt the steel, and by having carbon, it's great because it's conductive, but also it's very good at higher temperatures.
When the steel is melted, a separation takes place. Some of the materials rise to the top. This is called slag. Some of the good stuff stays at the bottom, more dense. The slag is removed from the top, leaving the pure material down below.
Iron from the Iron Age, the old world, the ancient societies all regarded Damascus steel, Damascus iron as the finest iron in the world. And literature would suggest, and scientific study, that the reason that it worked out so well in that area of the country, and the world rather, in Syria, was that they had a very nice wind coming in off the sea, and they had an elevation change. And in those mountains is where they built the Damascus furnaces. And they would take iron ore out of the ground, and they realized by combining it with what we would consider charcoal, because they had that nice wind coming through, they were able to really lower the amount of carbon in the iron mix. And by lowering the amount of carbon, you change it from being what we would consider cast iron, which is somewhat brittle, to a more ductile steel.
All through this process, the steel is tested both for quality and for temperature and for ingredients.
Just a bunch of kids playing with it, more or less.
Taking a core sample is one of the ways to test the steel. To do this, a portion of the steel is pulled away and sampled.
Well, they got hands like steel, they can hold those things.
Once it's cooled, it can be taken into a lab where the metal is placed into a mass spectrometer. This device scans and tells what is inside the steel that's just been cooled.
It makes it a lot easier as far as having a little understanding of what's going on here.
Just before it goes into casting, magnets are used once again. As the steel is squeezed down through the casting area, magnets surrounds the steel and causes the iron and the steel to form a nice, hard, uniform crust.
So Barry, we're in the control room for the casting part of the steel process. And so this is where that ladle of liquid steel comes over, and it's got to be formed into something you can use.
Exactly.
And so magnets are important here also.
Yes, they are. An interesting property about steel when it's cold, as we all know, is magnetic. When steel becomes red hot, even though it's still solid and it's red hot, above about 1,000 degrees Fahrenheit, it is no longer magnetic. Fortunate for us.
Now, wait a minute. So cold steel is magnetic. But you're saying red hot, so this property changes with temperature.
Exactly.
And when it's red hot, it's not magnetic.
Right.
That's crazy.
It is, and I don't understand why.
Does it always stay that, or does it change?
Well, once steel becomes liquid, then it becomes subject to magnetic fields again.
Why do you need a magnet then in this casting?
Well, in the continuous casting process, what we're doing is taking that steel that we've produced. Now it's the right grade for our customer. Now we have to put it in a usable shape. So we have to take the liquid steel, we have to solidify it. And as that's cooling in the mold, we introduce magnetic fields so that the cooling process is very even.
Because you really can't get in there and stir it up with anything, can you?
No.
So you could use the magnets to try to make it so it's consistent or the same type of cooling?
That's a great way to put it. In this rolling mill, there's 22 stands. Average horsepower is somewhere over 2,000, so there's about 50,000 horsepower making all these rolls turn. That's the shape it's going to be when it comes out. Each stand is a little bit larger ahead of it, so we control the shape as it processes through. And sometimes it's round, sometimes it's oval, sometimes it's a square with round edges.
Making steel always leaves behind a few scraps.
So you wait till a bunch of them get down there?
Yeah.
SDI uses magnets to make cleanup a snap.
The hoist that this crane is on is the ox hoist right here.
They even let me help out.
You can go pretty slow.
Magnets are also used in the final test of the steel.
I see the...
So it'll vibrate it, and then the particles will...
Special powder is put on a finished part, and a magnetic field is induced or put through the part. If there's any cracks or defects in the steel, you'll be able to see that through a magnetic line, like you see right here. After the steel is checked for cracks, there's one more time that magnetism is used at SDI to load the finished product onto the trucks to be shipped out to their customers. Magnetism at the start and the finish of the production of steel. The physical property of magnetism that works in the production of steel is the same type of magnetism that can work in your home or even in your classroom if you want to make your own electric magnet. I brought some of my favorite magnets to North Wayne Elementary, to Mrs. Binge's 4th grade class. We investigated how magnetic energy works.
Magnets are not attracted to gold.
A magnet has a north and a south pole, and with magnets, opposites attract. A negative pole will be attracted to the positive pole of another magnet. If you try to put two positive poles or two negative poles together, the magnets will repel each other or push away. Now, in science, whenever you talk about magnets, you have to talk about electricity. To produce electricity, you have to use a magnet.
And you can use electricity to make an electromagnet. It was time for Mrs. Binge's electromagnetic investigation.
Electricity passing through the wire magnetizes the iron. As long as the electricity is flowing through the wire, the bolt has the properties of a magnet, and it will attract other pieces of iron.
Turn off the electricity, lose the magnetic property.
They were making their own electromagnets, and they were seeing that the direction can change. They were pointing the bolt at one end, and the electricity was flowing in one direction, and then they switched it around the other way, and then they noticed, oh, okay, the electricity flows the other way. They love to do science because it's hands-on, and it also gives them the opportunity to ask questions. What else can we do? How can we elaborate on this? What other questions do I have? I know we have the question that's in the book, but then what else? What else can I do? How else can I tweak this? There's no right or wrong answer. You don't know. Your hypothesis may be totally way off base, but then you figure out why, and that's okay. Makes me feel like I've done something right. My best comment is, oh, is it time for lunch already?
The Earth itself is actually a magnet, and because of this, we've become much better explorers, thanks to something called a compass.
A compass is a small magnet that points to the largest magnet we know, the Earth's magnetic poles.
You add that to a map which uses true north and you can find your way.
This compass is acting very strange. It seems to be pointing towards Methodist Hospital. That means these compasses are useless. Let's go investigate what's going on with this anomaly.
One of the best ways to use a magnet or magnetism in medicine is with an instrument called the MRI, or magnetic resonance imagery. An MRI is a magnetic tool used to look inside the human body. And using a computer, they can turn those little changes or those little bumps in the magnetic field into a picture. We're at Methodist Hospital today to learn how magnets are used to save lives. The MRI is a relatively new device that opens up new ways to help people.
We're going to screen you to make sure there's nothing inside your body that could be dangerous.
So if I have anything metallic, because we've been learning that magnets are attracted to other magnets and things that have iron in them.
Mm-hmm.
Now, does this magnet do that also, but does it attract more things?
Absolutely.
Am I going to lose my feelings?
No.
Okay.
You've seen these magnetic cranes used in yards to pick up
You
cars
like scrap
and
metal?
yeah.
Yes, huh?
They're big, but those are only like about 150 gallons.
150 gallons, and how many gallons is this?
30,000.
30,000.
The
Wow.
Earth's magnetic pole is a half a gauss.
So this magnet we're getting ready to go in the field is much stronger than the entire Earth's magnetic field.
Oh, very much stronger.
Concentrated in a small area.
Right. In this building, and anywhere probably within 100 feet from this area, that is north.
That is north. Okay.
Okay, Rick, here are your scrubs. There's
Okay.
your dressing room. You'll just get dressed. I'll be back and get you shortly.
Thanks, Mike.
Okay, Rick, are you ready for your MR scan?
Let's go.
Okay.
I'm getting ready to enter Indiana's strongest magnetic field. I can't communicate with them because I'm not allowed to move. However, I can still hear them through this air tube. It's important that I stay very still in order for the MRI to take a nice clear image of what's going on inside of me. Using a magnetic field combined with radio waves, the MRI allows doctors to see right inside my brain. A powerful computer then converts this data into an image.
Are your legs okay? You want to push it under?
It's a 3D scan, which means that we can take the data that we collect and reformat it in any plane so that we can look at it from side to side, coronally, front to back, or axially, which is up and down.
Basically, we use a very strong magnet, like a background magnet, and then we have other smaller magnets, smaller electrical and magnetic fields that we change very rapidly, like radio waves. And that lets us take pictures of the brain or other parts of the body.
Right now we're taking a picture of the blood vessels in his head.
It lets us focus in on small details without using X-rays or other types of radiation. This lets us see very small, subtle changes that cannot be seen sometimes with lower field magnets or with other methods like X-rays.
Now, is most of your work looking at injuries or preventive medicine, or do you do things to try to find out like what makes people smart or how their brains actually work?
Well, actually, funny that you should ask. A lot of my work does involve injuries or when people get sick from unknown causes, but we also do research and we look at the function of the brain. And these types of very strong magnets that we use let us basically measure very small changes in blood flow in the brain that happen when you do certain things like tapping your fingers or thinking certain thoughts. And so a lot of people around the whole country are using these magnets as tools to study what goes on in the brain.
I know what's going through my head. I want to get my hands on this magnet. Okay, Mike, I brought some things that you might find in the classroom that we can try so kids can understand what this magnet's like. You ready to get started?
I'm ready.
Okay.
This magnetic tape is from a VHS cassette.
That's pretty cool. And this is a paper clip with a glove on it, definitely being affected by this magnet.
This magnet is so strong that it actually has an effect on some other metals that are not made of iron. This pan is made of aluminum,
a metal that is normally not affected by a magnet.
But as you can see, this very strong magnet is causing this aluminum pan to actually fall in slow motion.
1, 2, 3. A strong magnet like this even has a dramatic effect on steel wool wrapped in plastic.
So if this was in someone's pocket, they would
Be very dangerous.
Now, a magnet is a cool tool to use outside to find your way because all magnets point to the north, unless you're at the Methodist Hospital Radiology Department that has the strongest clinical magnet in the state. In that case, all compasses point to it. Physical science, the science that understands how things move or the physical properties of objects. We've learned a lot in this show. We've learned that magnets can be used to help make steel really strong. We've learned that magnets can actually save lives at the MRI. And we've had some fun learning about density, things that sink or things that float. Plus, I picked up a really cool new hobby, underwater bowling. Just be sure you grab the ball with the most density. And the next time we study density, we're making a butter suit. Are you guys ready?
Yeah!
What I need to know, do you believe in science?
Yeah!
Indiana Expeditions with Rick Crosslin is made possible through the generous support of the Dr. Laura Hare Charitable Trust, enhancing Indiana's natural environment through preservation and protection of ecologically significant natural areas, and promoting environmental education, stewardship, and awareness. CEFI, the Science Education Foundation of Indiana, investing in Indiana's youth by encouraging them to become scientists and engineers and to practice their careers in Indiana. Details at sefi.org. And the Center for School Improvement and Performance, Indiana Department of Education.